A fast food company is considering a new lunch item. The company will choose the item based on test market results. The item should show a higher weekly demand than one of the regular items on the menu. The analysis needs to show a difference at 0.01 level of significance to be selected. So we're going to do a hypothesis testing to see whether or not this new item is indeed has a higher demand than the regular item it's being benchmarked against. First thing to do is to write our hypotheses. So in this case, we will select this new item if it has an average. So mu of the new item is more than the mu of the current item that we are benchmarking it against. Therefore, the null hypothesis should be that it's actually either less or the same as the current. Now, once I have it written this way, I know that we're looking for mu of the new minus mu of the current is less than or equal to 0, and the alternate is the other way around. Mu minus current is greater than 0. So now that we know we are doing this, we know that we are doing a one-tail test, and we are right now looking at the differences of being 0. So let's go to our data, and in our data we see that we have recorded weekly demand. So these are in thousands. So when I say 17, it means that 17,000 for that particular time period. So we have collected data for new item and regular item, and now we can do the analysis. So go to data, data analysis, select the t-test, to sample assuming unequal variances. Variable 1 is in column A, variable 2 is in column B. Hypothesis difference right now is 0. I'm going to say that I have labels. I'm going to change my alpha level to 0.01, and I'm going to select the output range, click here, then click here, and press OK. Okay, so here's our output from our analysis, and what we are looking for is a one-tail test. So we have to focus on the one-tail test, and that answer is right here. So we are going to focus our attention in a one-tail test, and this is the information I'm looking at, and specifically on a p. And we see that our p is less than the alpha of 0.01, so we'll end up rejecting the null hypothesis. And what was the null hypothesis? The null hypothesis was that these two items sell about the same. So we are rejecting the null, which means the new item has a higher demand than the current item. Now we can go ahead and actually calculate that difference. Using the equation that we have, the difference between the means, it's simply the difference between this mean minus this mean. So on average, there is about 1.31 in thousands higher demand for new item versus the regular item. But this is just the middle of my confidence interval. I need to come up with a confidence interval. For that, I need my t-value. Let me explain to you that if I use this t-value, what I'm going to get is actually the 98% confidence interval. This t-value is for 0.01, right? And a one tail, which means I have the entire 0.01 here. And if I have 0.01 here, that means that you are 2.35 standard errors away from that hypothesized mean difference of 0. If I use the same t-value, remember, confidence interval is a two-sided value that you get. You get something plus and minus the mean. So there is an 0.1 also here, and that is negative 2.35. So if I use this, then I am talking about the 98% confidence interval. There is a 0.1 on this tail, and there is a 0.1 on this tail. So now we can calculate the standard error. Standard error is what you see in the equation, which is the square root of variance for the first variable divided by the sample size for that, and here it's 75, plus variance for the regular item divided by the sample size that we have for regular item. And again, if you notice here, I have different sample sizes. And as I have mentioned before, we are okay with that. We don't need to have same. So this is the standard error. So now the margin of error is simply the t-value multiplied by the standard error. So this is the second term in that equation. So now we are ready to calculate the lower bound and the upper bound of the 98% confidence interval, which is the mean difference minus the margin of error and the mean difference plus the margin of error. And we can make our life much simpler if I take this value and multiply it by 1,000 when I'm talking to people about what we have gotten from our analysis. What our analysis has shown is that the new item will sell more than the regular item, and it can sell by as much as 144 or as much as 2,480 or anything in between. So the confidence interval here is quite large. This seems to be a really a good addition if this was true, whereas this might not be as economical because there's a lot of cost that goes along with introducing a new item into the menu. It can be any value in here, and this might be a little too wide for management to have a useful information when it comes to making a decision based on the data that you have. They may ask you to improve the accuracy, and as you know, that comes with increasing the sample size. So right now, management might feel uncomfortable when you show something that is this wide.